In this section, we'll be taking a look at the Configuring and Monitoring EVPN objective of the JNCIP SP exam. For more detailed coverage of this topic, please check out the Juniper courses AJSPR, JL2V, and JL3V. In this video, we're going to take a look at EVPN configuration. So that's using this next generation protocol to provide an emulated broadcast LAN as an alternative to using VPLS. And to demonstrate this configuration, we're going to be using the same network that we've been using for all other Layer 2 service demonstrations. And that's what we see on the screen here. And we're going to take a look at the configuration from R1's perspective. So let's jump onto R1 and take a look at the configuration. So the first thing to note is that we're no longer using the family L2VPN signaling address family. We're using a different address family to support EVPN, and that's family EVPN signaling. So we would configure that on our IBGP mesh, on our IBGP sessions facing into route reflectors for distribution of the routes that are going to form the control plane of our EVPN instance. And then, like when you're configuring a BGP signaled L2VPN, again, we are using a routing instance to configure an EVPN instance. It's just in this case, we have an instance type and we are using EVPN in this case. And we're specifying the VLAN that's going to constitute our broadcast segment. There are other ways of configuring EVPN instances, but that's beyond the scope of this video. We're also specifying any PE to CE interfaces, as we would with any other routing instance, and we're specifying route distinguishers and route targets. Generally, when you're configuring EVPN routing instances, you would probably use a type 1 route distinguisher, so they would be PE unique, i.e. we'd be using a IP address here rather than an autonomous system number. However, for this simple example, it's sufficient to use a type 0 route distinguisher. And we have our route target as we would with any other routing instance. And then the only other thing that you need to configure is protocols EVPN. This is sufficient to enable EVPN for this routing instance. The way that you configure the PE to CE interface is slightly different. We have a different encapsulation type. We're using VLAN bridge in this case. One thing that's highly useful with EVPN that you don't get with VPLS is its integration with layer 3. I've not shown the configuration here, but if you wanted to integrate with layer 3, you would specify a routing interface underneath the routing instance. You would likely bind that to a IRB interface, and you would configure protocols, EVPN, default gateway, advertise. And what this allows the EVPN instance to do is to then integrate with layer 3 so that we can have hosts within the EVPN breaking out into layer 3 on the connected PE and then onward routing to IP destinations. If you were configuring a manual style integration, you would configure Anycast on the IRB interface, i.e. you would configure a static MAC and a static IP address to be the same on all PEs that are acting as default gateways for that EVPN instance. But that is broadly beyond the scope of this video and the JNCIP service provider exam. So in this video, we took a look at some of the basic configuration elements for EVPN. In the next video, we'll put it into practice and see the operation of a simple EVPN. In this video, we're going to take a look at the basic operation of a simple EVPN. And this is the topology of the EVPN we have configured. We're interconnecting sites 1, 2, and 3 on behalf of customer A in our service provider environment. So let's now have a look at a PE, specifically PER1, and see how this EVPN is operating. So we are using this EVPN signaling address family under BGP to advertise the necessary routes to establish our EVPN. There are two main route types that we are concerned about. So let's have a look at the EVPN routing table for this particular customer and analyze the different route types that we're looking at. So this is the full routing table for our EVPN instance. And with EVPN, route type is the first number you see in the route. So in this example here, this is a type 2 route, and this is a type 3 route. And a good way to filter this output is to use the match prefix option. So by using the 3:* syntax, we are filtering the output to only type 3 routes. Remember that we advertise type 3 routes to create multicast trees for the distribution of broadcast, unknown unicast, and multicast traffic. And we have 3 PEs in this EVPN. So we're seeing 3 type 3 routes to create the multicast tree from the perspective of R1. Protocol EVPN means that this is a route that has been generated by the router itself, and the protocol BGP are the routes that we've learnt from the neighbors. So with these routes, we build the multicast tree. We then have type 2 routes. Let's just take a look at the type 2 routes that we are originating first off. We're looking at the EVPN protocol type. And there are 2 variants of the type 2 routes. We are distributing this type, which is advertising the location of any MAC addresses that we are aware of. So this is the MAC address of a device connected to a CE that's interconnected to our EVPN instance. And we are telling other PEs about this MAC address location. The second type of route is that we are specifying MAC address to IP binding. Effectively, this is broadcasting ARP information within BGP. We're saying that this IP address is bound to this MAC address on a CE interconnected to this PE. And these are the routes that we're generating. We have a look at protocol BGP. We can see that we're receiving one of each from each of our connected PEs. We take a look at this one, for example. We're saying that this MAC address is connected to a CE connected to router 6. And we've also got the IP to MAC binding as well. We have the same for a CE connected to PE2. So this is how routing information is distributed within a EVPN. Show EVPN database shows us the resulting MAC to source binding information. We want to see the current status of an EVPN instance. Show EVPN instance extensive is a good command there. It's going to show us the connected PEs and how many MACs and how many MAC to IP bindings we're learning from those devices, and also how many multicast tree advertisements we've received from those devices. It's also telling us the status of any Ethernet segment identifiers that we have connected. We don't have any multi-homing configured in this case, so the ESI identifiers are all zeros. And you can see that we have only single-homed ESIs connected. I mentioned earlier that we are sending the MAC address to IP address binding information in type 2 routes. That allows us to build this EVPN ARP table. And this is useful if we had layer 2 to layer 3 integration, so that traffic going from the layer 2 domain to layer 3 and vice versa is going to happen on the most immediate PE rather than potentially hairpinning through the network. In this video, we took a very quick look at the operation of EVPN. This has been a JNCIP service provider certification preparation video for Junos Genius. Junos Genius is available on the web and as an app for many more certification resources. If you would like more detailed coverage of the topics covered in this video, along with much more content, the following courses are available from Juniper. AJSPR, which is Advanced Junos Service Provider Routing, JL2V, which covers Junos Layer 2 VPNs, and JL3V, which covers Junos Layer 3 VPNs. Thanks for watching.